Okay, all right. So here we go. So today what we're going to do is actually some word problems with graphing systems. All right. So meaning we give you a word problem, you graph it, and then you tell us what the answer to the word problem is. Okay. So let's take a look and see what that looks like. Okay. Okay, all right, here we go. So what we're gonna do today is let's do two examples together because these questions, I mean, reading it takes as long as solving them. So we'll do these two together as a class in the video, and then we'll practice when we come back. We'll just practice with as many of these as we can. All right. If I feel like we have to add one more day to the schedule, we can, but I wasn't going to. Okay. Now, some of you might say at this point, some of you might say, Mr. Ing, like word problems. Don't we do word problems at the end of the unit instead of like this early, right? In the unit. True, but these questions all involve solving these word problems with systems by graphing. Like all of these, as you can see. So I figure it's a good way to kind of break things up a little bit. Okay? All right, that's it. Now, right off the bat, we know that there's two characters here, Rowan and Jonah, and we already know we're gonna be writing like equations, right? So I'm gonna do this. Rowan, right? R of x, Jonah is J of x. Just easy to remember, all right? We don't have to do like f of x and whatnot. Now, okay, so first sentence, all right? Let me highlight this so they're easier to read. Let's use blue. All right, Rowan has 50 bucks in savings and putting $5 in every week. Okay, all right. So I already know what that even looks like. All right. So he's got 50 already. Put in $5 every week. I should have made that W, by the way. W for weeks. Okay, no big deal. Now, the other guy, let's use a different color. How about that? Jonah has $10 in his own jar and put in 15 every week. Okay, so and that just inspired me to tell you guys something about these sort of questions. Okay, Jonah has $10 in his own jar, but he puts in 15 every week. Now, very, very, very common sort of question. And what's so common about this, right? It's common because the way the situation set up is something like this, and I think this bears going over. Have you noticed, right, with Rowan, he started off with more money. Let me use Can I use a magic marker? Oh, that'll be so cool. All right. Hopefully it does what it's supposed to do. All right. You notice how with Rowan, he started off with $50, right? And Jonah started off with, oh, look how cool that is, right? Isn't that cool? All right. The thing just magically disappears. All right. So again, right? Rowan started off with a lot of money in the jar already, whereas Jonah didn't, right? However, Jonah's putting more money in every week than Rowan. So that set up the situation where even though Jonah started off with less money, he's gonna put in more money every week into the jar. So you can already see where this thing is going, right? Basically, it's saying, hey, at what point are these two guys gonna catch up to what it? Okay, at what point is Jonah gonna catch up to Rowan? That's really the question, and that makes it a classic system of inequality sort of questions. Okay, not system of inequality, system of equations question. Okay, something is stuck. I don't know what happened. All right. Okay. So that said, all right. Let's put this into the calculator. So let's see. Y equals 5x plus 50. What did I do? 5x plus 50. And the other one is 15x plus 10. Uh, is that right? Yep. Okay. All right. And I'm going to just graph it. Now, these guys are way up there because, you know, because the actually let me see if I could try zoom stat. It won't. All right, yeah. Zoom stat only works with stats. Okay, all right. So I'm gonna zoom out of the table, all right, because you can see the ends of those lines, but not the very top where the two lines meet. So let's see. Let me zoom out. All right, I'm gonna zoom out again. All right, now it's up there. So I'm gonna trace my way up there. As a matter of fact, I'm actually gonna zoom in at that part. I'm gonna zoom in actually. All right, so let's recap. I zoomed out just to see that the two lines do intersect, and now I'm gonna. You see how I move my cursor? I'm gonna zoom back in just to get really close to see where that is. Now, of course, if you want to look at the table values, you can, and I just want to see where y1 and y2 is the same, right? So you see how it when x is 0, right? Uh, Rowan has 50, but Jonah has only 10. After 1 week, that's where they stand. After 2 weeks, one guy got 60 in the jar, the other guy's got 40. You see where I'm going, right? So I really like this. This really makes sense, right? So you just keep going till the two numbers are the same. All right. Now let's see if the numbers are ever gonna be the same because over here he already. Oh, there we go. 4, 70, 70. I missed it. All right. So it's at 4 weeks. Oh, it doesn't even answer that. Oops. Should have read the whole question first. Okay. Rowan's graph at a steeper slope. That's not true, right? It's only 5x. Rowan's graph always not true, right? Because eventually they cross. Uh, Jonah's graph at a steeper slope. That is true. Jonah's graph, that's not true. So choice 3. But I wanted to make a point here. So if they were to ask you at what point are they going to have the same amount of money in the jar, your answer would be 4 weeks, right? If they ask you how much, you would say $70. Okay? Now, let's expand on the lesson a little bit, on the question. All right? I'm gonna go back to the graph and I'm gonna zoom in on that graph because I just want to look. So zoom in, right? I'm going to zoom in again. All right. I'm actually going to zoom in one more time. Because I just want to get as close since I zoomed out so much earlier. All right. I'm going to do it one more time. All right. By the way, I mean, this is why table values, I would think, even for you guys, who are doing this relatively for the first time, I think you guys can understand why table values is a little bit clearer. Okay. So look, 4. Yeah, look right here. 4, right? 4 weeks, $70. Okay? All right, let's do one more. So let me see how's the time doing. Yeah, good timing. Okay, all right. 9 next weekend. Let me get my highlighter. All right. I might not even answer the actual question because I'm trying to make a point here. All right. Marty wants to attend either Carnival A or Carnival B. Okay, Carnival A charges $6 for admission and 150 per ride. Now again, right? Notice what I'm doing. I'm already taking notes as I'm going. Okay, it's more efficient. All right. So Carnival A. So they want what? They want you to use notation. Look, it's like a 3-part question actually. Write A of X to represent. So A of X to represent the total cost of attending a carnival. Okay, A of X is $6 for admission, and then $1.50 for every ride. All right. Now let's keep reading. Carnival B charges $2.50 and then $2 per ride. Carnival B charges $2 per ride and then $2.50 for admission. Right? Now, so okay, I wrote that. Yep, I'm done. That goes right over here. B, determine the number of rides can go on so that it's the same. See, you see where I'm going? So now they want to see where do these two lines intersect. All right, so let me go back to the calculator. Clear, clear. Now what else? 1.5 x plus 6, 1.5 x plus 6, and then 2.5x plus 2. Is that right? Yeah. Okay. All right. Now let's graph this. Whoa, what happened there? Hold on. Did I zoom in too much? Let me go back to standard. Oh, there we go. Huh. I didn't know they remember that. That's interesting. Now let me zoom out just so that I know like where to zoom back in later. All right. Yep. Okay. So I'm gonna zoom in right now. It's kind of funny actually. You have to zoom out just to zoom back in. All right. So here I'm gonna go here. Zoom in. I'm gonna zoom in some more. Again, you obviously can use a window. I mean, you know, no window, not window. Table values. Okay, so I'm gonna zoom in again. Zoom in. It's about there. All right, let me see if I could surmise a solution. My guess is gonna be 4 and 12. All right, that's my guess. All right, let's look at the table of values. Yep, bingo, right? So by the time you go for 4 rides, it would have cost the same, $12 each. Okay, so the number of rides, so 4 rides. All right. Marty wants to go on 5 rides. Which one is better? So there you go. Good old substitution. Oh, it's 5 rides, of course. Okay. Oops. Yeah, no wonder they come out the same. Yeah, 5. Okay, 1.5 times 5. Where do I write this? 1.5 times 5 is 7.5. 7.5, so $13.50 for A. What about B? 2.5 times 5. That's 12.5. 5 times, yeah, 12.5 plus 2, right? 12.5 plus 2 is 14.5. All right, so ride A. Ride A is cheaper at 5 rides. Okay. All right. Okay. All right. That's it. All right. Hopefully I didn't make a mistake there. But let's come back to class. Okay. All right. See you there.
OMG, that was so good.